All right, some more equation solving. And they're going to get a little trickier. Everybody have out your calculator because we're going to have to do some by graphing today. And you need your unit circle, of course. Okay, I'll work on that. All right, guys, I need somebody to tell me how to do this one. What can I do to problem number 1? Good job. Factor out a cosine. So this said sine times cosine. Sine times cosine. When we pull out the cosine, it'll just say sine. Then this one said minus 3 times cosine. So we'll just have a minus 3 when we take out the cosine. Okay, we can't divide out a cosine. Now we're going to take your turn being equal to 0 here. Either the cosine's equal to 0 or sine x minus 3 is equal to 0, which would make the sine 3. No es posible y. Okay. There's no amplitude change. It just says sine x, so it only goes between -1 and 1. Okay, if you tried inverse sine of 3, you'd get an error on your calculator. The cosine, on the other hand, if we didn't have a unit circle, we could look at the graph. Do you know the 2 places that it crosses and makes 0? Or you can look at your unit circle. Okay. Are we done? It does say all. And why do we know it's 2 pi n that we're putting on there? Because it says all, and it would be all the way around one more time before we'd find an answer. And also because, look right here. The cosine has a period of 2 pi, right? So that's how long till it would repeat. Repeat again 2 pi later. Is there a shorter way to write that particular one? When you looked at your unit circle, did you notice that they were straight across from each other? So you could have just said, well, here, and then everywhere straight across from that forever. But I'm okay with the longer way, okay? Yep. Those of you who just like to think about a little bit of a puzzle, you can try to write it shorter. Okay. Number 2. Is there a trade for something we could do here? Is there a trade for sine? We had a discussion about this in 5th period. Sine plus 1 doesn't have a trade. Sine doesn't have a trade. Only squared things have trades. So, oh, what? This is what we know, right? Okay, so we don't have that. But I can rearrange this one and take a cosine squared and trade it for a 1 minus the sine squared. Would that be okay? So it isn't real pretty. Oops, it becomes a 1 minus sine squared plus a sine plus a 1. Which of those can I combine? 1. Okay. The 1's combined to be a 2. Now, this is what I'm left with. I don't like that. Some of you can factor that with no problem. It always messes me up when my first is not a positive number here, my a term. So we could move it all the other side. We could multiply through by a -1. Doesn't change anything, right? That's legal. So I really have sine squared, all the way through. Hofbauer would change that to a minus sine x. Minus 2 equals 0. Okay, now it looks a little better to me. Those of you who get stuck on this factoring stuff, it's something squared minus the same thing minus 2. So, I don't know. We'll say today's Riley's day. We'll pick R. How does that factor? Yes, you are. Okay, so it's going to factor sine minus 2. Oh, I lost the x. I try not to do that. I know, I don't care if you do, but. Okay, if I set this one equal to 0, I get the sign is 2. If I set this one equal, I get the sign is negative 1. 2 is not possible. And how often would that repeat? Are we good? Okay. The next one changes directions. It says on the interval and including 0 up to 2 pi, but not including 2 pi, right? Because 0 and 2 pi are really the same answer, same place on the unit circle. So we only want to call it one of those, says call it 0. But we don't have to put any more what? Plus or minus 2 pi n. In our final answer, eventually we're going to do somewhere we need to use that until we're done. But this is looking ugly. Is something equal to secant minus 1 is Kate's question. I think it'd have to be a secant squared minus 1. Okay, what is the relationship as it's stated on your blue sheet, guys? 1 plus tangent squared equals secant squared. Okay. Okay, so tangent squared is secant squared minus 1 plus a secant that was already there and another minus 1 was already there. So we end up with a secant squared plus a secant minus 2. Now, I think somebody's freaking out because there isn't any secant on my unit circle. We'll get there in a second. Right now, it factors how? Okay, 2 and a 1. And I need to have a positive 1 for my middle term. So plus 2 and minus 1. Does that work? All right. What does that mean? The secant of x is 1, or the secant of x is negative 2. Let's just worry about these a piece at a time. This means 1 over the cosine is 1, which would make the cosine have to be, this one's going to be, but this one's just 1, right? Okay, where's the cosine 1? Okay. This one says the secant is negative 2. Well, that would mean 1 over the cosine is negative 2 over 1. I could do some cross multiplying and dividing, or I could just flip them both over, right? And the cosine would be negative 1/2. And where is that true? 2 pi over 3 and, okay. What did the directions say for this question? This is what we have so far for our answer. There was something else in the directions. What did it say? Graph to check your solutions. Okay. So in our calculator, we are going to, I don't know what we're going to do because I'm making a mess of this. Okay. We're going to graph the equation And the original equation said tangent squared x plus secant x minus 1. How do we type that in? Tangent of x, close parentheses, squared. I think that works on all of them. I used to have to type parenthesis tan x close squared, but I think it'll work if you just put it on the outside of the parenthesis now. All right, plus, how do we type secant? And we don't need extra parentheses. You just do 1 divided by cosine. And then minus 1. And what are we looking for on our graph if it's supposed to equal 0? The zeros are the x-intercepts, yes? Okay. We can do a zoom trig to start. What mode do we need to be in? Okay, had trouble with that this morning. Mode radians. We can start with a zoom trig, but it's going to give us too many answers because it said in the directions we only want what? So if we go to window, we can change the x values to 0. And I'm literally going to type 2 pi. And it'll do it for me. All right. We're looking for zeros. How many zeros are there in this window? It looks like 4, but I think the last one is actually right at what? 2 pi, and our directions up here said not to include that one. So we could do trace and type 0, 2 pi, and 4 pi, but I think it's going to jump to those 3 spots. Are we good? Do you know what I'm saying or not? If I went trace 0, oh, yep, that's one of them. Trace 2 pi over 3, oh, sorry. Trace 2 pi over 3. And it would jump to this one and so on. Okay? We're looking good. All right. Number 4, does anyone have an idea how to start this one? I don't think we can divide because we'd end up dividing all 3 terms and we'd end up with kind of a messier thing. I think we're going to have to square both sides. But when we square both sides, we're going to have to FOIL this out over here. We get 1 plus cosine times 1 plus cosine. I'm leaving off my x's. But what is that going to look like after we FOIL it all out? Everybody see where we got that middle term? Okay. Equals. What's happening over here? Square root of 3 squared. It's just 3. And this is multiplying, so we don't need to FOIL it out. It's just sine times sine or sine squared. Okay. That got us really far. Yeah. Sine squared is 1 minus cosine squared. So we are finally looking like at least we only have cosines, right? We have to distribute the 3. You do a little algebra on your paper and see if you can get that all to one side. I'm thinking, yes, I would not make one this gross on the test just because I'm thinking everybody would get it wrong. That is a trade for sine squared on our unit our blue sheet, it says cosine squared plus sine squared is 1. So if we want to trade it for sine squared, we can write sine squared equals 1 minus cosine squared. So we did this replacing this. Okay, I don't have mine in a nice order, but what I do notice about it is that I can take out a what? If I divide out a 2 or factor out a 2, I'm also going to rearrange it. I'm going to put 2 cosine squared first, then the cosine, then the minus 1. Did I lose you there? All right. What do we need to do with that 2 out there? Because 2 doesn't equal 0. That's a good option. Okay. So this is 2 Riley's squared plus a Riley minus 1. I just picked a letter to use for today for how we're going to simplify this. Just because some people really struggle how to factor this, but it just factors. We actually have 2 Rileys in this class, remember? Plus and minus here, does that work? 2 minus 1. So it factors 2 cosine of x minus 1 and cosine of x plus 1. All right, moving on down the page. This means cosine of x would equal what? Positive 1/2 or, okay, I've forgotten what we were supposed to do. Find 0 to 2 pi, yes. We only need the answers from 0 to 2 pi. Okay. Cosine is 1/2 at pi over 3, 5 pi over 3, is that right? And negative 1 at pi. Okay. Do you remember when I said it was especially important to check your answers? When you square both sides. So I'm a little concerned. We squared both sides. Let's see what happens. What was the original equation that I can't see anymore? Oh, it was easy. 1 plus cosine of x equals. Now, I'm going to do y1 and y2. Is that okay? And then see where they intersect, since I have 2 sides. And it was square root of 3, arrow to the right, times sine of x. Or not. I don't know what I did there. All right. Ooh. When I graph that, what am I looking for this time? Because I put it in y1 and y2. Intersection points. How many intersection points do you see? Only 2. Now, my window goes out. Turn this back on. My window goes out to 2 pi. Okay? That's supposed to be a 2. So I'm thinking this is pi. So does it look like they intersect at pi? But there's somewhere else. Looks like pi over 3, huh? Okay. So these 2 seem to work and this one doesn't. I'd like to talk real quick about why. If I plug it back in, it would say 1 plus cosine at 5 pi over 3 equals square root of 3 times the sine at 5 pi over 3. I'm trying to check this answer why it doesn't work. Everybody okay? I didn't have much room to write that. What is the cosine at 5 pi over 3? So I get 1 plus 1/2 equals square root of 3 times, what is the sine at 5 pi over 3? Negative square root of 3 over 2. Square root of 3 times square root of 3 is 3. So I end up with this. Does 3 halves equal negative 3 halves? No. So that's why that one didn't work. Okay. And again, I kind of sort of promised that there's probably not going to be one on a test or quiz where you're going to end up having to throw out an answer, okay? All right. How are we going to do this? We can just use our calculator, okay? Now, it talks about a way to use it involving symmetry, to solve it involving symmetry, but honestly, we can just graph it in this window and we'll be fine, okay? Since we have graphing calculators, let's go for it. We're going to put in sine of x and negative 0.729 and graph. What? How many times does the sine graph hit negative 7.29? Twice. Okay. The solutions are not going to be pretty because it's nowhere in my unit circle, right? So I need to find the intersection. Now, I will tell you on some of these problems, in order to find the intersection, you really have to get close with your guess, or the calculator struggles to find it. This one isn't too bad. All right. I know this is a struggle for some of you, but it says round to the nearest. How many decimal places? In the directions? Okay. Some of you don't follow directions well. I think it rounds to 9585. Does that seem right? Okay. We need to find the other intersection points. Which means you got to scroll over close to it. 5.4663. Bossmo is right on top of that. Okay. Are we done? It said only between 0 and 2 pi, and it said decimals to that many decimal places, so I think we're good. But now what? Okay. This says all solutions, okay? Yeah, it is a sine graph. The period is 2 pi, so we're just going to put plus or minus 2 pi. Let me talk about that rough sketch thing for just a minute. What the rough sketch part was talking about was if I graphed this, when I typed in my, I could, without, before I had a graphing calculator, I would have had to type this. Can you do this for me? Oops, negative in here, sorry. Just go to the home screen and type inverse sine negative 0.729. What do you get? Just give me 2 decimals. I'm too lazy to do 4. 0.81? Negative 0.81, right? Okay, that's because your calculator found the closest place to the origin. Do you see where this is negative 0.81? That's not between 0 and 2 pi, right? But, follow me just for a second here. You can do this. That means this little bitty yellow distance is 0.81 long, right? So back before I had a graphing calculator, I had to say, well, this little yellow distance is also 0.81 then. So I would say pi plus, oh, sorry, can't read that. Pi plus 0.81 is one of the solutions. And this little bitty yellow distance was also 0.81. Do you see that? So my other answer was 2 pi minus 0.81. Type those in real fast. You should get these decimals. Obviously, I rounded, but nobody wants to do them that way anymore because you have a graphing calculator, right? Okay, because this was a little tiny bit past pi, and this was a little bit back from 2 pi. That was minus, okay? Had to do with the symmetry. We had to do them that way because we didn't have graphing calculators. You guys have graphing calculators. You can just find the 2 decimals where it intersects. We're good. All solutions means we add what, though? Because the period's 2 pi, we add plus or minus 2 pi n. All right. Moving on. Can we talk about, oh, this one. Forgot about this one. This is just a graphing calculator question. If you look at that, do you have any idea what that's going to look like? Yeah, me either. Okay. Because it doesn't even have a common period, right? It's just a mess. So type it in. 2 cosine 3x close parenthesis minus 3 sine 4x close parenthesis. Graph it. Oh, it's supposed to equal 3, which means I want to do what? Yeah, put another equation in that says 3. I'm even going to go back and make mine bold just to be difficult, but you don't have to. How many intersection points? You arrow to the left and then hit enter, and you can choose from some things. You can make it dotted, whatever. If you have the color, you can arrow to the left and change the color. All right. 4 intersection points. These are a little bit tricky to find, guys, because you do have to arrow close to them. Okay, so choose intersection, enter, enter, but then for the guess, you want to be close or it has a real hard time finding it. Okay, 4.0315. Okay, can I let you guys find the other 3 and tell me where they are? If I remember right, there's another one in the 4s and one in the 5s and one in the 6s. Okay. Somebody besides Basma find one for me? Somebody go find that last one. 1916. Okay, sorry. And 54. Intersection. No, shouldn't be. Did it say intersection or was it still on guess? It has to say intersection or you haven't hit enter enough times. Okay, go back to your equation. You have to have something typed in wrong. 2 cosine 3x. Okay. All right, we're good, guys? All right, I want to try this one without a calculator, without a graph, anyway. You can do this. How would you do this? Back when you were in the first week in this subject, or back in geometry, or back in algebra 2, if you had this picture, you would have said, oh, if I want to find that angle, tangent is 6/1, and then you would have done what? You would do this, right? Type it in your calculator to find the angle. So do that. You were in radians, not degrees now, but one more? 6? Okay. I don't have a graph. How do I know how long till it's going to repeat? It's tangent. The period is pi. So I'm going to put plus or minus pi n. If you actually graphed this, most of you between 0 and 2 pi, you would have found both of these 2 solutions. And then you would have put plus or minus 2 pi n because you wouldn't remember. But actually to get from this one to the next one is exactly pi. So this is the answer. The easiest way to write the answer. If you wrote it in a more complicated way, it'd be fine. All right, you do have to change the window to find that one because your Zoom trig doesn't go up to 6. All right, now we're getting to the meat and potatoes of the lesson. Ready? This is where all the good stuff comes from today. In the past, when we did this, 0 to 2 pi was the easier ones, right? Today, on these kind, we're going to call U substitution because of this in here. It's actually easier to find all exact solutions most of the time. All, not just the ones between 0 and 2 pi, because you don't have to do the last step. All right, here you go. We're going to start by finding the sine of U equals negative square root of 3 over 2. Okay, unit circle. Tyser, can you tell me where that's true? Where's the sine square root of negative square root of 3 over 2? Everybody okay? Does that seem right? How often would those repeat? Okay, so that's what U is. We'd be done, except it doesn't say U, it says what in there? 2x. So we're going to change this back to 2x. And now we need to do what to find x? We need to divide everything by 2. Some of you struggle with fractions. Use your calculator. You can also, instead of dividing by 2, could we multiply by half? That's the same thing, yes? You do have to do everything by half. So that one will become x equals, what's half times 4/3, or 4/3 divided by 2? Math, enter, enter. Okay. Plus or minus, what's half of 2 pi? I need someone to explain to me why that actually makes sense. That was plus or minus pi n. Guys, when you graph the sine of 2x, how would you graph that? It has a period of what? Pi. If it has a period of pi, does that make sense why we are only adding pi here? Okay, now tell me what we get when we divide this one all by 2, or take half. X equals 5 pi over 6 plus or minus. Okay. This is the answer. We're done. We did good for number 10. Number 9 is actually better to do second because it wants all the answers between 0 and 2 pi. Remember my little picture up here? How many times did it hit a negative value down here between 0 and 2 pi? 4 times because the period was only pi, right? So what we're going to do to find those, we're just going to use this. We're going to say one of them is 2 pi over 3. One of them is 5 pi over 6. How are we going to find the other two? What did it say to do here to find another answer? Add pi. So do 2/3 plus 1, or 2 pi over 3 plus 1 pi. What's 2/3 plus 1? What if I added another pi, though? Would that be outside of 2 pi? Yeah, can't add 2 pi to something unless it was negative, right? And stay within there. Okay. So one more answer. 5, 6 plus 1 pi would be... Okay, we just found all 4 answers. Okay. These 2 questions I would like to skip. You would graph this, and you'd find the intersection points, and they're just going to be ugly decimals. Does that seem okay? I think you have something like that on your homework. Because all of worksheet 4 is actually on the homework check for those of you who haven't been writing anything down. Hope you've been writing things down, because this is actually part of the homework check. Okay. But 4B being part of the homework check, I'm still volunteering to do numbers 1, 3, and 8 with you if we can get through those, okay? Deal? All right. Now, this is a 2 theta in here. So that's going to be our downfall. Besides the fact that it just looks ugly to begin with. So we're going to have to do a U substitution. We also eventually want the answers only between 0 and 2 pi. But we're going to start off by pretending we want all the answers, and then we'll worry about this. All right, so ignoring the 2 pi, I'm just going to call that U for a minute. Now, this is a disaster, but how can we isolate the cosine? What do we need to do to get the word cosine all by itself? Divide by -8, which someone made up some big numbers that would really simplify down to what? Yes. Does everybody see that? 4/8, that's a half of a square root of 2 would be root 2 over 2. Okay, so it's really on our unit circle. They just made it look hard. Okay, where is that on our unit circle? 2 places. Three pi over 4 and okay, and normally it would say plus or minus 2 pi n if we were looking for all solutions because it's a cosine graph, yes? All right, but we did a substitution. We did a substitution for 2 theta, so how do we need to solve for theta? Okay, take half of everything. Half of this, half of this, half of this. It will now say 3 pi over 8 plus or minus pi. Half of this will be what? Plus or minus pi. Okay, we're finally ready to find our answers. Want to shoot me? I know you do. Okay. 2 of the answers are 3 pi over 8 and 5 pi over 8. Yay, we have 2 of them. But we can add a pi to that and still not be bigger than 2 pi, right? So do 3 divided by 8 plus 1, math, enter, enter, and you get what? It's 11 pi over 8. You were doing this one. No, you're not wrong. If you do 5/8 plus 1, you get 13/8. Now, can I add more? Because if I add another pi, then I've really added 2 pi to, yeah, be too big. Okay, no crying in pre-calc. Stop crying. I know you're all crying. Let's try this one. All right. Again, they made this a mess. It's not really a mess. 1 plus, I'll call it the tangent of u. Oh my goodness, that's so messy. Plus tangent of u equals. Okay, over here, I'm going to rewrite that as 3 over 3 plus square root of 3. No, I wanted to just call this u for a moment. Yep, okay. 3/3 is really 1, right? So if I get that up, oh, look. Yeah. They're just trying to hide the answer from us. The tangent is square root of 3 over 3. Now, good news is tangent has a period of pi. We only need one answer, blah, blah, blah. The bad news is that's an ordered pair people have trouble finding. Can you remember how that has to look so that the tangent will be square root of 3 over 3? It's that one, right? So when we do 1 over square root of 3, we'd get square root of 3 over 3. Okay? So where is that ordered pair at? Pi over 6. Okay. And it would repeat every, because it's a tangent, pi. So if you want to look at the graph, it also is the same down at 7 pi over 6, but we don't care because it's going to repeat every pi anyway. All right. But what do we have to finish up with? Yeah, this is 2 theta. Okay, so if we take half of everything, we get pi over 12 plus or minus pi over 2. Half here, half here. Are we okay? All right. Now, one of our answers is pi over 12. Yay! Now add a 1/2. Do 1/12 plus 1/2. 7/12. Add another half. Add another half. That's the question. Add another half. Okay. Why does that one not work? 25/12 is more than 2, right? It's 2 and a 12th. So we get to be done with these 4 answers. Depends on what it's asking. Because we're going to do this one, and guess what this one's over? We have a 3. This is number 8. Guys, make sure you're writing this on the right spot, okay? Can you do some finagling with this crazy business they have over here? We'd have -2/2 plus square root of 3/2 equals -1 plus the sine of u. Okay, -2/2 is -1. If we add 1 to both sides, we just have this. Why are they so tricky trying to hide that? Okay. Pi/3 and 2π/3 plus or minus 2πn. You're going to like this, guys. What did the directions say? All solutions. Are we done? Not quite, because we still forgot to do what? Yeah, we still got to do the divided by 3, but then we get to be done. Okay, so divide by 3 means take a third. So 1/3, 1/3, and 1/3. You'd have pi over plus or minus 2/3 pi n. That's supposed to be an n back there. Okay. If we had to find all exact, we'd have to keep doing 1/9 plus 2/3 until we got past 2. If it said 0 to 2 pi. But it says all solutions, so we get to be done. What's the other one, though? Got to do a third of this one. So it is actually both of those. All right. I did 3 out of the 8 questions on the back for you, okay? All right, so this is what you need to work on finishing up. The homework check on this stuff is due Friday. Tomorrow we're going to do most of worksheet 5 together, which is the other part of the homework check, okay? What did you do wrong?